Okay, so we've looked at some linear patterns, right? We've looked at patterns, and we said they're linear because when you put the dots on that graph, then they make a straight line, okay? So we've had charts where we had the numbers matched together, like figure 1 was 3, then figure 2 was 6, etc. Today what we're going to do is we're going to look at being able to write an algebraic expression that represents any pattern, right? And I know you've seen some patterns before, but we just want to formalize this because it's going to be one of the things that you're going to be working on your assessment. It's a big part of it. It also gives you an idea of how you can build these patterns for later, okay? So what we're going to talk about is the difference rule. For most linear patterns, again, linear because they would make a straight line.
It's not the correct version of the test.
Okay. So we can use this difference rule to be able to build the rules for any linear pattern. Okay? So what we need to think about is, let's say that you have a pattern. Right? And remember that the top number, we'll just call it n, represents the number figure it is, right? The first figure, the second figure, the third figure, the fourth figure, right? And then you have bottom numbers on the bottom, excuse me, which are the actual number of matchsticks or whatever you're using, right? Remember we counted those matchsticks and every time there were 2 more, something like that. Well, if we use letters are called what?
Algebra.
Right? It's algebra because of the letters, but what are the letters called? Variables. There you go. The letters are called variables because their value can vary. So you see that I'm using n, but n can be 1, 2, 3, 4, right? And on and on and on. I'm using t, but t could be 2, 4, 6, 8, and then on and on and on. Now I'm starting with a really easy pattern so that you can see exactly what's happening. Let's talk about what's going to happen to get the pattern, the steps for getting the pattern. The first thing we're going to do is we're simply going to find the number of increase or decrease. Remember yesterday when we did our patterns, we learned that they can either be going up or they could be going down, right? Increase means they're going what? Up. Decrease means they're going down. Excellent. And the way we're going to do that is simply subtract. Right? Now, on a simple pattern like this, you don't even need to think about it too much about the difference. But if you see, to get from 4 to 2, right? 4 minus 2 is what? 2. 6 to 4, 6 minus 4 is what? 2. 8 to 6, 8 minus 6 is 2. So do you see that they have what is called a common difference? You see it? It's the same number every single time. They're always 2 units apart. Well, that number that we get is our multiplier. Okay? So this gives our multiplier. So that tells us for this particular pattern that no matter what I'm doing, I'm going to be multiplying by 2. And the thing that you're going to be multiplying by, it's always going to be times your n. And n is just the top number, the number for the figure. Okay? So in this case, this rule would start off with a multiply by 2, so that would be 2 times n. But remember that we're trying to get t. We're trying to get a rule that will always give us our t. So that means t is equal to 2n so far. Now we can see if that is enough. So if I take my different numbers and test them, what is my first n that I have up here? 1. So let's see if that works. T equals 2 times 1, because you remember you never put a number. Remember we did evaluating and substitution last time. So you never put a number in without putting in place of a letter without putting it in parentheses. So that gives us 2 times 1, which is 2. If n is 1, is t 2? Right here from our chart? Yes, right? So that one's true, but we can't just test 1. We've got to test more. So let's just jump here and see if this one works. You don't have to test them in order. If it works for one, it has to work for all, though, right? So let's see. Our t has to equal 2 times our number. What is our number for this particular column? 4. So t is equal to 2 times 4, which is 8. Is that true for that number?
Yes.
Absolutely. So we can conclude then that our pattern is simply 2 times our n. Okay? Well, not all patterns happen that way. Let's look at another pattern. Sometimes there's going to be more to it. I know it's boring, but I'm going back to black. Say we have 1, 2, 3, 4. Okay. And our pattern is 3, 5, 7, 9. Again, fairly simple pattern, but it really doesn't matter because the process, no matter what the numbers are, the process is always the same. So the first thing I want to do is use that difference rule to find my multiplier. And remember, all I need to do is simply subtract the t's, right? So if you look at 3 and 5, 5 minus 3 gives me what? 2. 7 minus 5 is the next one, gives me what? 9 minus 7 gives me? So we know that our multiplier then is 2. Does it always have to be 2? No, it just happened to be the example that I chose because you know I always keep it simple. So that gives us our multiplier. So I know that part of my pattern is going to be 2 times n, right? Gives you your multiplier, whatever your times you're in. But this time, if I test it, let's see if it works. What is our first t value here? Well, our first n is 1, but our first t is 3, right? So let's look and see if that gives us what we need then. So I'm saying 2 times our n, right? Remember the tops are n's, bottoms are t's. So 2 times 1, which gives me t equals 2. Is 2 the number that I got for my first value? No, it's not, is it? What should I have gotten? A 3, which tells me then that the number that I got is not enough, right? But I can use the difference again to be able to find out what I need to put on there. So I can use the difference again. The difference between the number I got, that comma shouldn't be there, and the real t from the chart. Okay? It's a very simple pattern. So what was my real t? 3, right? But what did I get? So if I just subtract them, I find out that my number is really 1 too small. 1 smaller than what I need, right? Okay, because my t was bigger than the number I got. So that tells me that I need 1 more. Make sense?
How do you get 1 more?
Well, we're going to have 1 more. So what does 1 more look like? If you wanted to say 1 more, that means I need to what? Add 1. Right?
Where does that 1 come from?
Well, the 1 comes from, you take your t, right? And subtract the number that you got when you tried we already knew the multiplier was 2, right? That's never going to change. But when I did 2 times 1, I only got a 2, right? But what I needed from my chart was not a 2, but I needed a 3. So I took the 3 minus 2, right? That's all right. It's fine. If you have the question, other people might too. So I know that my number was 1 too small, right? So I needed to add 1 more to get it. So instead of t equals just plain old 2n, it's going to equal 2n what? Plus 1. And it works every time. So it's the rule of differences. So we're going to do some together, and then we're going to work on. Then you're going to work on some on your own until we can make sure that everybody's got that, because it's a really important part of what we're doing. Yes. Keep it. Okay. All right. So let's go to Education Perfect and look at some examples. Okay, so they're going to describe it a little bit differently, but really you're going to be seeing the same thing. We're just using the rule of differences, right? Which differences always means what operation? Subtract. Come on, guys. You know that. Difference always means subtract. So we're always going to be subtracting, but we're going to be subtracting twice. First time to get our multiplier, right? And then we're going to test one of the numbers. If it works out fine, then we're good. But if it doesn't, we need to subtract again to find out how much we're either adding or subtracting, because you might need more, but you may need less, right? What happens if the numbers are going down? Then you're going to need less, right? So we're going to talk about how. So we know that we can find the value of a particular term in any sequence just by counting the matchsticks or finding the pattern. But we need to be able to write a rule so then we can find any term. Because what if I asked you for the 2,396 number? Do you want to count up 2,396 of all of those matchsticks? That's a lot of matches, right? But if we have an algebraic rule or an expression, then we're able to find it no matter what number it is. Okay? So that's what we're going to be looking for. Okay? Okay, here we go. So, in a previous lesson, we found that value of t when it was very big because they gave us the formula. They gave us the pattern. But what we want to be able to do is we want to be able to find the pattern for every term. Okay? So, here's a pattern. Very simple pattern. Okay? And we know that for the first one, for the first figure, the value of it is 1. For the second figure, the value is what? 3. Good. For the third one, the value is 5. Right now, I just want to make sure that everybody knows exactly what we're talking about when we're reading the chart, right? Okay. The fourth value is 7. The fifth value is 9. And so we can assume, therefore, that it goes on that way forever, right? So what we want to do is find the rule for the value for the nth term. In other words, any term. Okay? All right. So what we can do is we can use that rule of differences to be able to accomplish that. So if you look, though, if we do 1 minus 1, we're going to get what?
0.
So sometimes the first number doesn't tell you much, does it? Because if I multiply by 0, I'm just going to get 0, aren't I? Okay? All right?
Then you could do n minus 1.
Right. So what that tells me is that you're not going to get the first one, but look at the second one. Say we do 2 minus 3. What are you going to get? Minus 1. Okay? That tells me that my pattern is going to need a negative number. But that's perfectly fine. Let's see if it holds true. 5 minus 3 gives me what? What kind of 2? Minus 2. Okay? So, all right, wait a minute. I'm doing the last part first. I should be subtracting the t's, right? I forgot to get our multiplier first, didn't I? I was looking at the other part. Sometimes I worry about me. I hope y'all do too. Okay, let me try that again. I need to get the multiplier first. How come y'all didn't tell me that? That was a test. So we're going to subtract the t's. Remember, the first step is to subtract t's, not the numbers, but the t's. So my second t is 3. So that's 3 minus 1, which gives me a 2. 5 minus 3, which gives me a 2. 7 minus 5, which gives me a 2. I would test at least 2 of them, but once you find out that what's happening with 2 of them, then you could pretty much assume it's all the rest of them are going to do the same, right? But you can test as many as you like just to make sure. So what is our multiplier? 2. So we know that we're going to have 2n in our formula. Okay? Now, let's now do the second part, which we're going to first test the first t, or the first n, I'm sorry, into your formula. So our first n in the formula is 1, right? And I want to multiply that out and get another 1. Well, t equals 2 times 1 gives us t equals what? 2. 2 times 1 is 2. Now, is that the number that I wanted to get, though? No, because the number that I want to get is a 1. But that's easy enough. We'll just use the law of difference, or the rule of differences again, and subtract that number from what I have, right? So what number was my t supposed to be? 1. So we'll subtract 1 from what I got. So what's 2 minus 1?
1.
So that tells me that the number I got was too big by 1, right? Because I'm 1 apart, but I started with a bigger number, but my number should have been smaller. So if I want my number to get smaller, am I going to be adding the 1 or subtracting the 1? If I want it to get smaller, subtracting, right? We need to subtract the 1 to get it smaller, right? So my formula is not just 2n, it's 2n minus 1. Okay? So it's just doing the difference twice. First, you'll do the difference of the t's, right? Then you'll test your formula on the very first number, and if it comes out right, then you've got your formula. But if it doesn't, subtract your t from that, and that'll give you the difference that you need. So let's test this on one of them. So let's test it on 5 and 9. So t equals 2 times, it's the fifth number, right? So 2 times 5 minus 1, which gives me 10 minus 1 when I multiply that out. And what is 10 minus 1?
9.
Is that what I wanted?
Yes.
You bet it is, right? When n is 5, I wanted t to turn out to be 9. And it did. Okay? Now we're going to look at several. This is all we're doing today. So if you don't quite get it, don't worry, because we're going to do several. But what I want you to concentrate on, that I didn't, is concentrate on the rules for it, right? So let's finish writing this rule. You test the first number, subtract the t from the result, and see, do you need to add or subtract to get what your real value is? So again, you're just going to be subtracting twice. First subtract t's, then test your first number and subtract your t from that to c. So you're always subtracting the same things, the t's. Now, let's look at another example here. Okay. All right, so here we go. We've got our chart. We've done this one already. Let's look at another one. Okay. We just did that one too, didn't we? All right. Let's go to our homework, and I'll do one of your homework ones, just so we can be sure. Here we go. Here's a pattern. All right. So, and they'll walk you through it too. So it's good to go through the homework so you can see exactly what you're going to be doing. The pattern, numbers in this pattern increase by blank each time. So what we need to do first is use that subtraction rule, that difference rule, to be able to see how much they're changing. Okay? And most of the time, you could do this part in your head. 1 to 6 is how many numbers?
6.
Be careful.
5.
Right, the difference between them. So, yeah, 5. And to get from 6 to 11, you're also another what? 5. You guys want 6 so badly. And then from 11 to 16 is 5 more, right? So that means that our multiplier, we're increasing each time by how much? 5, which tells us then that our first part of our formula is 5n. Now, I know y'all can find the differences because y'all blew that Kahoot away yesterday, right? Okay, so you know how much difference there is, right? Just so finding the difference between each one. So you can do that by just counting, or you can do it with subtraction. 6 minus 1 gave us 5. 11 minus 6 gave us 5, etc. Right? So the common difference is 5, and that's our multiplier. Okay? I guess I should type that in so that we can check the answer, but we're not going to. Okay. Now, I know it's 5. If y'all trust me this time. All right? So we know it's 2n. Each term in t is something more than 2n. So in other words, I need to find out now the other part of the subtraction. So what I'm going to do is I'm going to test my formula on my first n. So t equals 5 times n. Oops, I'm sorry. 5 times my first n is 1. So that gives me t equals 5. But if n is 1, should my t be 5? No, it should be what? 7, right? So this number now is too small, isn't it? Okay? Too small by how much?
1.
Yeah, well, not 1, but what? 2. If you just subtract them.
1 minus because you keep tricking us.
No. I'm not tricking you. So you're just going to see how much bigger is my real t than the one I got. 2. So that means that my formula needs to be 2 bigger. And 2 bigger means what? Add 2. Okay? So my true formula then, we think now, is 5n plus 2. So let's pick one of these and test it. So there's 5 and 15. Okay? So our n is 5. Let's see if it gets us the right number. 5 times 5?
25. 27.
Is that what we wanted?
No.
So it didn't work, right? So am I still on the same rule? So we changed numbers because I went to the different screen. So we had t equals our 5n. They're just not asking for the whole thing here. So now, let's see if if we use 1, does that give us the 3 we want? So t equals 5 times 1 gives us t equals what? 5. But is 5 what I wanted? No. What did I want?
3.
So 5 minus 3 gives me a difference of what? 2, right? But the number I got was too big by 2, right? So am I going to add more? No, I need to take away some. So it's not add 2, but what? Minus 2. So now let's test one of the numbers and see if that works. T equals 5 times, let's just go ahead to the 5. 5 minus 2, which gives us 25 minus 2, which is that what we wanted?
Yes.
Absolutely. So you see what happened was I changed the... When I went to the next one, I thought they were just going to keep going with the same one until they were finished. They didn't. All they wanted here was just this part. But I don't like that. I want us to have all of it. Okay? So they changed numbers on me. Okay. So what I'm going to do is I'm going to give y'all one. You can work together as a table on this because we want to make sure that everybody's getting it, right? So, okay, I'm going to put one on the board. I want you to do it from start to finish. I want you to tell me everything about the pattern. What is the rule, right? So you should end up with t equals something in either plus or minus some number, right? You know what the rule says. So here's some numbers. Let's just use those. Go. You have 1 minute. You can work together.
It's 3. It's 5 and 1.
Okay, hold on a minute. I changed it because it didn't change the numbers. It was the same one. So go use this one. We'll start over. Go. Okay, so the first thing I need to do is to subtract my t's. Well, 10 minus 8 gives me 2. 12 minus 10 gives me 2. And so I'm getting a multiplier of what? 2. So I'm pretty safe with that, right? So then I know my pattern is going to start off with 2n. Well, they already told you that, right? Okay, so the next thing I need to do is find the amount of either, what is it called when it's going up? Increase, or the amount it's going what? Down, right? So that I need to find out if I have to add or subtract something at the end. And I do that again by finding the, starts with a D, difference. Good. So first thing I want to do is just test my first number. So what is my first number? 1. So t equals 2 times 1, which gives me a t of what? 2. But is 2 what I wanted there? What did I want there? Okay, 8. Now, so I simply subtract those to find the difference. What's 8 minus 2 going to give me? 6. We'll just all work together. That's fine. All right, so that means they're either getting bigger or smaller by 6. Bigger or smaller? Increasing. So we need an increase of 6, so that looks like what? What's an increase look like? What operation? Plus 6. Increasing by 6 more, right? So now, let's test one of the others just to make sure that we get the right pattern. Always go back and test one of the others. So t equals 2 times my 5 plus 6. 2 times 5 is? 10. Plus 6 gives me, is 16 the number I wanted? Then I know my pattern works. Okay? Just the rule of differences. So just taking the difference, but you got to do the difference how many times? Twice. Does that make it look a little clearer? Because we're going to do another one. Or y'all are. Okay? Are you ready? Again, we can do it as a group if you want to. Talk it out. And then we're going to try one all by ourselves each time. All right. We ready? Go. Find the pattern. Okay, so let's talk about it. So,
Let's talk about it. Right?
who wants to tell me what pattern y'all got? The whole rule.
T equals 3n minus 1.
T equals 3n minus 1. Do you agree?
Yes.
Excellent. So let's talk about how you got it. First thing we did was we subtracted our t's, right? So think about the steps. First, we'll subtract t's to find the difference. So 5 minus 2 gives me what? 3. 8 minus 5 gives me. So I know that my multiplier is going to be a 3. It also helps that they told you that, right? So I know that it's going to be t equals 3n. But now I need to test the first number. So that's the second thing you need to do. Test the first number, your first n. So to test my first n means that instead of the n, I'm going to put what number? 1. So it gives me t equals 3. Is that what I wanted it to be? No, right? So that means that I need to find the difference. If there is one. Now remember, in the first pattern we did, there wasn't a difference, was there? But this time, so if I take 3 minus 2, I get a difference of what? 1. But was my 2 1 too small or 1 too big? Smaller, right? So that means, so the 3 I got is too big. So in order to get from 3 to 2, I have to not add 1, but what? Subtract 1. So there you go. How can I make sure about that pattern, though? Test another one. So let's go over here and test our 5. T equals 3 times 5 minus 1. What's 3 times 5? 15 minus 1 gives me, is that the number I wanted?
Yes.
Boom, you're all geniuses.
Yay.
Don't you love it? Okay. This is a really abstract idea. So if grasping this is a really important part of being able to do algebra. You're using unknowns to develop a rule that works every time. That's a really important skill. Okay, so we did it when it was written as a table. Do you think you can do it when it's written as pictures? You want to give it a shot? Okay. Well, all right. We'll find the difference together, and then you work on it. Let's do this first one. So if you look at the first figure, right? This is the first figure, and our T is simply how many matchsticks it takes, or lines it takes to make that stick figure, right? So let's just count them. 1, 2, 3, 4, what? 5. So in the first one, we have 5 lines, right? Let's go to the next one. 1, 2, 3, 4, 5. We already knew that. It's always going to stay the same because of the first figure. So the only one we really are interested in is how many did they add to it? 1, 2, 3, 4. So 5 and 4 make what? 9. So what is the difference there? 4. So we already know the first part of our formula, don't we? Okay. All right. Now, let's test our first one. How many? Our first one was figure what? Figure 1. It always is, right? So T equals 4 times 1. So T equals 4. Is that what we wanted? No, we wanted it to be a 5. Well, 5 minus 4, is what? 1. Okay? But was the number, guys, I wanted too big or too small? So that means my 1 is not subtracted, but what? Added. So there you go. So it's the same thing, except this time we just have to count the number of lines instead of they're giving us the number on the chart. Okay? So here we go. Y'all are doing the next one. Okay. All right, they're just describing what happened and making a chart. Let's see if we can do that. All right, you ready? Here you go. Work together. Go. You got 1 minute. First, we need to decide some numbers. Give some numbers. Well, we know that's the first pattern, right? So our N is going to be 1. And how many lines does it have? 6 lines, right? So be careful when those cross. Now, if there was a little space between them, you could see that would be more lines, right? But if it's solid, that means just one long line. So now we need to know how many in the second figure.
11.
Right. We have our original 6 from there, plus 1, 2, 3, 4, 5. So that's 11. And the difference between 11 and 6 is 5. So that means our multiplier is going to be 5. So we're going to start with T equals 5N. You happy with that?
Yes.
Now, we need to test the first one, right? You're always testing that one. So T equals 5 times 1 gives me T equals 5. Is 5 what I wanted? No, it's too small by what? By 1. So that means what do I need to do? Add 1. Then you can just test the second one if you want to. T equals 5 times 2 plus 1. Gives me 10 plus 1, which is? And is that what I wanted?
Yes.
There you go. So you see, you can do it also from just counting. Now, but when you count, write down the numbers, right? Okay?